Okay, we're going to go through the coordinate geometry assignment now. I'm not actually going to go through number 1 because I inadvertently actually did it in a lesson, so check your book for notes. Number 2, always start by drawing your diagram. It doesn't have to be too accurate, just give you a basic idea of what's going on. So plotting the points A, 3, 2, B, minus 4, 3, and C, 5, 6, and D, 4, 1, so something like that. Show that the lines AC and BD are perpendicular. Well, AC I think was something like that, and BD something like that. So they look perpendicular at first sight anyway. So what I need to do now is do my differences in Y's, divide that by my differences in X's. So for AC, that is 2 minus 6 over 3 minus 5, which is equal to minus 4 over minus 2, which is equal to positive 2. For BD, I get 3 take away negative 1 over minus 4 minus 4, which gives me positive 4 over negative 8, which cancels down to minus a half. To get your 5th mark here, you have to say, because minus a half times by 2 equals minus 1, lines are perpendicular. And that gave you 5 marks. The next part required you to use the formula y minus y1 equals m x minus x1. You know your gradients, you just found them, so your gradient is the m part there, and you just substitute in either a's coordinates into the y and the x, or c's. It really doesn't matter, and you should get what they get in the question there, which is 2x minus y minus 4 equals 0. And that is the equation for AC. For BD, you would substitute in the values for B with its gradient being minus a half, and you should get, for BD you should get x plus 2y minus 2 equals 0. If I go back to the question, the next part asks me to find the coordinates of E at the point of intersection of AC and BD, and you should be thinking straight away that this just means simultaneous equations. Okay? Whenever you've got two lines intersecting, it's telling you they're simultaneous equations. What are the equations? Well, I've just worked them both out. In GCSE, you used to see that these values here, the minus 4 used to be over the other side, so you get 2x minus y equals 4, and here you'd have x plus 2y equals positive 2. If you want to think of it like that, that's absolutely fine. Just in A level, we tend to have everything over on one side, so it's equal to 0. In terms of how you want to solve that, you can use the elimination method, you can use the substitution method. There's loads of different methods you could use. It really is up to you. I'm going to solve it using the elimination method. I'm actually going to multiply this equation by 2 to get 4x minus 2y minus 8 equals 0, because I quite like the elimination method when you can add the equations together. So if I add those two equations together, I get 5x, 2y's cancel, minus 2 plus minus 8 gives me minus 10, equals 0, x equals 10 over 5, and x equals 2. Now I've got the value of x, I sub that in, let's say into BD, so I get 2 plus 2y minus 2 equals 0, and you'll notice that the 2 minus 2 actually cancels out, so I'm actually left with 2y equals 0, so y equals 0 divided by 2, which is actually 0. So E's coordinates are 2, 0. Finally, you're asked to find the length of AE. If you want to think of your coordinates for A, we had that it was 3, 2, and for E we've literally just found it is 2, 0, so it's actually by there. And I'm thinking of Pythag here. I've got my right angle triangle there, very small drawing here. My x distance goes from 2, we got that 2 there, over to the 3, so that is an x distance of 1. And my y distance goes from 0 up to 2, so that is a y distance of 2. Doing my Pythagoras theorem then, it is 2 squared plus 1 squared, all the other way around, which gives me root 4 plus 1, which gives me root 5. And that's that question complete. The third question was as stated, so again, start by doing a small diagram. It doesn't have to be absolutely spot on, it's just designed to give you a vague idea. So minus 2, 3, so somewhere about there, 10 minus 1, so all the way down here, and 3, 8, and I'm asked to find the gradient of AB, so I want to know this one here. So straight away I know I'm expecting a negative answer. It looks like it's going to be fractional to me. I might be mistaken though, it depends, it's only a quick diagram. So I'm thinking differences in y's over differences in x's, and I am going to get 3 minus minus 1 over minus 2 and take away 10. So that gives me 4 over negative 12. I can cancel that fraction down, so the minus is going to come outside by the fraction here, and that would be minus a third. And that is what I was expecting just from the look of that line. The next part says to find the equation of that line and find the equation of CD. So to find the equation of that line, I would do my y minus y1 equals m x minus x1. I've just found what m is. M is my minus a third. So I can substitute in my values. I will choose coordinates. I'll choose coordinates A. Be careful of your negative in with the x here. So you've got x, and that turns to a plus 2. In lessons I said I don't like this third here, so I'm actually going to multiply this side by 3. So I'm going to get 3y minus 9 equals, and that minus 1 is still here, it didn't come over as a minus, x plus 2, and then I get 3y minus 9 minus x minus 2. Pulling everything onto one side, I get x plus 3y, and I'm going to get minus 7 equals 0. If you notice, I didn't rush this line. It's easy to make mistakes here. If you want to eliminate the chance of making mistakes, just take your time. Going back to the question, I'm told that the line through C, perpendicular to AB, intersects at the point D. So if I put my line here at C, perpendicular to there, makes that right angle, so I know what gradient that line's got to have, and I want to know what D's coordinates are. Before I find D's coordinates though, I need to find the equation of this line of CD. I know what its gradient must be. Its gradient must be positive 3, because 3 times that negative third that I had earlier gives me minus 1, which I know is the condition for perpendicular lines. Substituting in C's coordinates of 3, 8 into my y minus y1, we'll find the equation of that line. So y minus 8 will equal 3x minus 3. Simplifying, y minus 8 equals 3x minus 9, and pulling everything onto one side, I get 3x minus y minus 1 equals 0. Again, I've got two equations now to work out where I can work out d through the intersection of those lines. So again, I could use a number of methods here. I'm actually going to have this equation here. This equation here I'm actually going to multiply by actually no, I'll change my mind. I'll multiply this equation by 3 so I can add the equations together. So I get my first equation, just that top one, which I'm just writing out literally just the same again, x plus 3y minus 7 equals 0. And my second equation, I'm going to triple this one here to get 9x minus 3y minus 3 equals 0. Now when I add these two equations together, I get 10x, the y's cancel, I get minus 10 equals 0, x equals 10 over 10, and finally x equals 1. Sub my value into equation 1, and I get 1 plus 3y minus 7 equals 0, 3y equals 6, y equals 2, and I've proved that D has the coordinates 1, 2, which it told me in the question. Final bit, it says that E is the midpoint of AB, so if I do x1 plus x2 over 2, and I do y1 plus y2 over 2, I will find E's coordinates, which should be 4, 1, I think, by the time we finished. Now I know E's coordinates and I know D's coordinates. I could have a look at my drawing again. So D being 1, 2 and E being 4, 1. It looks something like that. I've got a very small triangle here. I know that's 1, 2. I know that's 4, 1. So in terms of my values here, the x distance is 3, the y distance is 1. It is the root of 3 squared plus 1 squared, which is the root of 9 plus 1, which is root 10. And that concludes the assignment. Hope that was of some help.